Support comes from the Missouri Forest Products Association. Missouri produces wood pallets, railroad ties, white oak barrels, hardwood floors, and more. Details on the variety of products made in the state are at choosewood.com.
Welcome to St. Louis on the Air. I'm Don Marsh, and a Happy New Year to you all. At the end of 1811 and the beginning of 1812, this part of the country was rocked by a series of earthquakes so powerful they were said to ring church bells in Boston and New Orleans and cause the Mississippi River to run backwards. There are some who say it could happen again and that it would be catastrophic for present-day St. Louis. Is that fear justified? We are, of course, in the same seismic zone that triggered the quakes 2 centuries ago. Joining me to talk about temblors and the new Madrid fault is Michael Wysession, professor of Earth and Planetary Sciences at Washington University and executive director of the Teaching Center there. Michael, Happy New Year to you.
Happy New Year, Don. It's a pleasure to be back.
Good to have you. Okay, the new Madrid fault. How significant is it?
So the new Madrid fault is unusual for the United States in that it is a region that has had significant seismic activity in a place that is not along a plate boundary between tectonic plates. If you look at a map of earthquakes around the world, most earthquakes occur where the tectonic plates are shifting. Either they're sliding past each other the way they are along the San Andreas Fault in California, or they are colliding the way they are in Japan, or they're pulling apart the way Africa is separating along the East African Rift Valley. These areas have high numbers of earthquakes. They occur regularly and consistently. There are a few places in the middle of the plates, and New Madrid is one of those, where you do get elevated levels of seismicity. These are much more difficult to understand and much more difficult to make any form of forecast for future seismic activity. The largest reason is they don't happen very often, and we don't have a good history. So in the case of the New Madrid fault, as you mentioned, there were these large events. They were high magnitude 6s in December of 1811 and January of 1812. And then a magnitude, best guess is a magnitude 7.2 that occurred in February of 1812. And these were felt large distances around the eastern U.S. Trying to take that one seismic event and forecasting into the future has been proving to be very challenging.
Let's just clarify one thing about the tectonic plates. What the heck are they?
So every planet cools down over its history. So Earth, as the other planets in our solar system, was largely molten at its formation 4.5 billion years ago, and over time it has cooled off and lost its heat to space. Each planet, depending on its size and composition, cools off in a different manner. For Earth, it seems to be the only planet in our solar system. That process involves plate tectonics, where most of the top half of our planet, which is the rocky mantle, is slowly convecting. Think of a pot of soup boiling on the stove. Only the motions are in the order of centimeters a year, the rate that your fingernails grow. On top of this cooling, convecting rocky mantle are chilled layers about 60 miles thick, and these behave largely rigidly, and they move about the surface as a piece of, imagine eggshells on a hard-boiled egg that somehow managed to be sliding around across the top of the egg, banging into each other. When they collide, you form mountains. When they separate apart, you form oceans. And our entire geologic history at the surface of our planet is a direct function of the history of the motions of these tectonic plates.
I gather from what you've been saying that you're not anticipating a big one for this part of the country.
Well, straight off, let me say no one knows. And it's a little embarrassing as a scientist not to be able to answer that question. If I studied volcanoes, Because of the way that volcanoes occur, with magma cracking its way to the surface, releasing gases, causing higher temperatures, I might be able to predict a volcanic eruption down to a day. That has been done in the past. The way an earthquake occurs is very different. Imagine taking a pencil and bending it until it snapped. You might not know anything about when that snap would occur until it actually happened. It's the last straw that breaks the camel's back. And often for many earthquakes, we get no warning before that earthquake occurs. So we've not been able to predict earthquakes. And we've even found the forecasting based on probability to be very challenging, because it's not like the seasons or day and night where you can predict exactly when winter and summer are going to occur. For earthquakes, even regions that have had earthquakes going back as far as we have human history, they've never occurred in a regular manner. So we can't tell you, unfortunately, when the next large earthquake would occur.
What magnitude would we have to be looking at in order for St. Louis, with its many bridges and many old buildings, to experience a problem?
Well, this is a very important question, of course, because earthquakes pose both a hazard, that's the natural part, that's the amount of energy released when the ground snaps, and they pose a risk, and that is the damage to our infrastructure, the loss of life, the human impact as a result of that. And for the New Madrid earthquakes, St. Louis is in a pretty good place. Now, we do have historical evidence from 1811 and 1812 because there were over 5,000 people living in the St. Louis region at that time. And there were structures and buildings, and when those earthquakes occurred, some loose chimneys fell down. There was not much damage beyond that. But we also didn't have skyscrapers. We didn't have, certainly, the infrastructure we have today. But it's interesting because there were places half the distance to New Madrid, still right along the Mississippi River, places like St. Genevieve, where not a pane of glass broke and not a brick fell from those earthquakes. So the way the seismic waves propagate is also not simply a function of distance. It's a function of the type of rock underneath. And it's a process we have learned now since being able to examine closely large earthquakes elsewhere, of the focusing and defocusing of the seismic waves. For the 1989 Loma Prieta earthquake in San Francisco, we found that some blocks were largely obliterated by the focusing of the seismic waves, and you could have a block, 100 meters away, which was largely entirely undamaged. No panes of glass were broken. And that sort of randomness, it also shows our inability to sort of make predictions on a large scale.
There's a report online from the Missouri Department of Natural Resources quoting a 1990 FEMA report estimating damage and injuries in St. Louis from a 7.6 magnitude quake, and that's more than what you anticipate was or deduce was the situation in 1811, 1812. The damage and injuries, $2.8 billion in damage, 260 deaths, and 1,000 serious injuries. Does that sound right to you?
Well, one good thing about science is we do learn more over time. And that report you mentioned, that 1990 FEMA report, was based on the assumption that the geology in the middle of the continent here in Missouri and Illinois is the same as the geology in California, where we've had multiple large earthquakes. And in California, if you look at the magnitude 7 earthquakes that have been there, you can see how much the shaking fades away as you go with distance. For the eastern part of the United States, the crust, the tectonic plate, is older it's colder, and so seismic waves will propagate farther, but they don't cause any more damage. Imagine you have two chocolate bars. I always love using food as an analogy.
I'm with you.
And you have one that you take out of the freezer and one that's been sitting out on a warm day, and you bend both of them. Well, the one that is very cold is going to make a very loud, audible snap. The one that is warmer and softer makes a very quiet snap. You might not even hear it. That analogy plays out for how we've understood our earthquakes. In California, the crust is very warm. It's active. There are volcanoes that are actively occurring there. So the waves don't go very far. Here, the last volcanoes that erupted were 1.5 billion years ago. The rock is colder and stiffer. So, for instance, there was a magnitude 5 earthquake over in Indiana about a decade ago. We felt that earthquake here in St. Louis. People felt it in Kansas City. That was a small magnitude 5 earthquake, but the waves propagated great distances. Think of that cold, snapping chocolate bar. So the earlier predictions for the sizes of those earthquakes, based on the fact that people felt the shaking from the New Madrid earthquakes of 1812, all across the eastern U.S., made people say, "Oh, that must have been a magnitude 8 earthquake. That must have been, or a 7.6." We now have reassessed that, and probably the best study was done by Susan Huff, a U.S. Geologic Survey seismologist whose father was a historian and had access to records from gazettes and newspapers all across the country in 1811, 1812. And she has reevaluated, knowing the geology that we do now, those earthquakes as being high magnitude 6s, and as I mentioned, her best estimate is a magnitude 7.2. We also have to look at, however, the history of seismicity since then. So the last time we had a magnitude 6 earthquake in the New Madrid area was in the 1800s. It's been over 120 years since we've had a magnitude 6 earthquake, and it's been over 40 years since the 70s that we've even had a magnitude 5 earthquake. And in general, earthquakes follow pretty closely a fractal law, where if you have a magnitude 7 earthquake, in that same period of time, you should have 10 magnitude 6s, 100 magnitude 5s, and 1,000 magnitude 4s. Well, the seismicity in the New Madrid area has almost shut off entirely. Now, I have to clarify that and qualify that, because the level of earthquakes in New Madrid is still slightly higher than what you would expect in a purely random place in the middle of a continent. And we did a good experiment to compare that. Washington University recently participated in a deployment of seismometers in Wisconsin, Minnesota, and Canada, looking at an ancient rift, a billion-year-old rift there in the middle of the continent. So we had 85 seismometers operating for 2 years. During that time, we detected 6 earthquakes a year, a total of 12 earthquakes. Most of them were magnitude 1 earthquakes, very small. To give you a sense, a magnitude 1 earthquake is about the size of a small quarry blast, 2 sticks of dynamite. In the New Madrid area, over the last 20 years, we've had 817 earthquakes. Most of them are magnitude 1s. And that works out to be about 40 earthquakes a year. Again, mostly magnitude 1 earthquakes. There was one magnitude 4 during that 20-year period. But if you extrapolate that number of earthquakes up to the number of 5s you would expect, or the number of 6s you would expect, or the number of magnitude 7s you would expect, you are looking at thousands or maybe even tens of thousands of years before the next magnitude 7 earthquake. So based on the seismicity that we see happening today, we don't see any indication that there will be a large one of that scale anytime in the near future.
Well, that's very reassuring. We have to take a break, but I want to pick up on one of the points you made, and we'll do that. We're talking with Professor Michael Wysession of Washington University, and obviously we're talking about earthquakes and the threat of earthquakes here in the St. Louis area. Back in a moment. This is St. Louis on the Air on St. Louis Public Radio 90.7 KWMU.
Thank you for listening to this St. Louis on the Air podcast supported by University College at Washington University, with undergraduate and graduate programs part-time, evening, and online. University College at Washington University, offering world-class education within reach.
Welcome back to our conversation about the earthquake threat to the St. Louis area, real and imagined. I've heard it said before that because the New Madrid fault is fairly active, you say an average of about 40 a year, that this releases some of the pressure, that it's a good thing to have frequent small quakes rather than wait with the pressure building to have a bigger one at some point. Is that factual?
Well, ironically for earthquakes, that ends up not being the case because all of the magnitude 4s that occur along any given fault, pick Japan or any fault in the world, is a tiny fraction of 1 magnitude 5 earthquake. And all of the magnitude 5s that occur are a tiny fraction of 1 magnitude 6. So if you look over the last 100 years for all of the world's earthquakes, almost all of the energy released is by the largest 1 or 2 earthquakes. It's a earthquakes are a very unusual phenomenon in that sense that the earthquakes are happening almost continuously. There are millions of earthquakes that happen every year, but most of them are very small and release almost no energy. But it's that one random event, the giant magnitude 9 in Japan or something, that will release vast amounts of energy and cause most of the damage and most of the deaths. So lots of small earthquakes don't actually relieve stress. However, there have been cases where when those low levels of earthquakes shut off, and that means that the fault is now locking. And there have been cases where large earthquakes have been preceded by a shutdown entirely of seismicity on the fault. That said, there are also cases where large earthquakes have had foreshocks and the level of seismicity has increased. So we can't use either way as an indication of a large earthquake because both of them can occur beforehand.
Well, they're experiencing and have experienced recently in Southeast Asia a couple of doozies. Tsunami, a result of it, a large loss of life.
Right, that's right. Yes, and that was a horrible disaster that very much mimics the 1883 eruption of Krakatoa, where 30 or 40,000 people were killed by the tsunami. This also seems to have been a volcanic eruption that caused that tsunami. Tsunamis are an unusual phenomenon that can be caused from underwater landslides and volcanoes as well as earthquakes.
And there was a 4.4 magnitude quake in Tennessee just a few days ago.
That's right. And that is important to remember in any, my general message here is that the risks along the New Madrid fault are lower than many people probably fear they are. However, there are earthquakes that can occur anywhere. There was a magnitude 6 that occurred outside of Chicago in 1909. You can go to almost any place in the world, and if you go back far enough, there has been an earthquake there. Our continent, North America, is billions of years old, and it's filled with cracks and splinters from multiple collisions with continents in the past. And it's also moving westward over a fairly lumpy mantle, moving, at about an inch a year, slowly, but that causes the plate to bend and flex. And we also recently just had a large ice sheet at the end of the last ice age disappear. If you were in Chicago 20,000 years ago, you'd have been under about a mile of ice. And that sudden removal of ice has caused the northern part of North America to suddenly rebound. And it's going up at about 1 centimeter a year, and that causes bending that has been released by earthquakes. So there are a variety of factors that can lead to the bending, the accumulation of stress that will be released as an earthquake.
Was the Tennessee quake the result of the New Madrid fault?
No, the Tennessee seismic zone is an entirely different fault, and there are multiple ancient faults. In the case of the New Madrid fault, it's an ancient rift that was active about 750 million years ago. And the crust here was stretched and thinned, and that's why the Mississippi River runs through it. The water will always take the lowest elevation, and so the river runs down through the axis of this ancient rift zone.
I have a caller I want to get to and will in a moment, but first I want to clarify the one thing that I mentioned in the introduction, and that is this newspaper report that came out recently talking about the next big one and how awful it would be for St. Louis, talked about liquefying the area. That sounds terribly frightening to me. What is it?
Well, liquefaction is a process by which the pressure from seismic waves, as they travel through water-saturated soil, actually pushes the sand grains apart. So if you think of like wet sand, if the pore pressure of water inside that sand increases, it can actually push the sand grains apart so they are no longer touching, and they momentarily, while these waves go through, behave like quicksand. So there have been cases where whole buildings and structures have suddenly sunk into the ground over a matter of seconds. The seismic waves go past and the ground solidifies, and now your second floor apartment is a garden apartment. This has happened in places like Japan and others. There is evidence, paleoseismic evidence, of this happening in the St. Louis region, and sometimes this creates things called sand boils. The pressure is so great underground that the wet sand will actually erupt at the surface as a small geyser, and people called paleoseismologists have gone and dug into the ground and found evidence of these as an indication of past earthquakes in the region.
What magnitude would we be talking about if that were to happen?
Well, you see, that's the problem. We have no idea. It could be a very small earthquake right there at that location, or a larger earthquake farther away. Both would have the same effect. So if you see this paleoseismic evidence, you have no way to assess what the size of that past earthquake was.
All right, let's take that phone call now. Tony's joining us from Wildwood with an issue that I wanted to get to, so let's have Tony do it. Go ahead, Tony.
Good day. Two questions. Lunar tidal effects on earthquakes and volcanoes, and fracking earthquakes, doing things like changing the pressures in various parts of the plate. Okay, thank you.
Sure. Thank you very much for the question. Yes, two of those are very fascinating areas of research. It does turn out that the changes in the tidal stresses do have a very small statistical effect on earthquake effects. In other words, if you compile and analyze decades worth of earthquakes, there is a very slight correlation between active seismicity and places where the tidal stresses are greater. It's a small effect. It doesn't cause giant earthquakes, but it is part of the stress cycle that affects earthquakes. Now, fracking is very important. We, as humans, are significant agents of geologic change on our planet, of course, in many different ways. And one of them is we now can cause earthquakes in large numbers. And of course, Oklahoma is the classic example, but Missouri and Arkansas and other states as well. If in the case of Oklahoma, they for years had about 1 magnitude 3 earthquake a year for the whole state. During the peak of the pumping of the fracking fluids, they had got almost 1,000 magnitude 3 earthquakes and above, and some magnitude 5s that actually caused some damage. And that wasn't the fracking that caused the earthquakes, but taking those fracking fluids, which are filled with a variety of chemicals that are fairly toxic, so they are not allowed to be kept at the surface. They are pumped down deep, sometimes as deep as 5 kilometers, and it's the pumping of those fluids occasionally into ancient faults that would lubricate an ancient fault and allow it to occur. So it wasn't the case that wherever you pumped the fluids, you got the earthquakes. But it was the case that wherever you got the earthquakes, you had pumped the fluids.
There was a piece in the Post-Dispatch this morning saying that because of new fracking regulations in Oklahoma, the number of those small earthquakes has diminished considerably over the last year or so.
And that is a marvelous success story of industry and government organizations and universities working together. They've all cooperated to create a protocol where, as the pumping of fracking fluids occurs, if the seismicity even begins to elevate a little bit, they slow down the pumping, they change their pumping rates, and they have been able to significantly contain and reduce the number of fracking and process-induced earthquakes. Yes, that's a wonderful story.
A final question for you comes from Megan, a listener in Belnor, who is asking me to ask you, would you get earthquake insurance yourself here?
No. But I have to say, as my insurance agent has told me, it has to pass the sleep test. You have to be able to sleep at night knowing what kind of coverage that you have. The deductibles that come with earthquake insurance tend to be very high, as in $5,000 or $10,000, and the damage that would occur here from an earthquake would be cosmetic. It might be some cracks in the bricks. There was a magnitude 2.5 in East St. Louis about 14 years ago. I felt that in my home here in St. Louis. And so I'm more concerned about a smaller earthquake directly under St. Louis. But for me, we've been tracking very closely the accumulation of strain that occurs in the New Madrid region. And there was a study in 2012 that showed that there is some small amount of bending that's occurring. This uses GPS devices, much like the ones that are in your phone, but they deploy them in the ground continuously for years or decades. And the accumulation is on the order of 0.1 millimeters a year. As much as 0.37, and that was the largest that they found in that study. And their assessment was you could possibly have enough strain accumulating, bending accumulating, to get a magnitude 7.3 earthquake every 500 years. But again, that assumes that this bending rate that we've seen over the last decade is the same as what will be occurring 100 years from now. And because we're not on a plate boundary, there's no continuous motion of the continents across here. That's a big leap of faith. But it is possible. And so it's really up to what you're comfortable with. But the risks are so low in St. Louis. The probabilities are so low. They're not zero, but they're low that no, I don't have earthquake insurance myself.
Well, that is very reassuring. Michael Wysession, thank you so much for being with us. Great to talk to you again. And Happy New Year once again to you.
Thank you very much, John. Happy New Year to you.
Michael Wysession of Washington University. This is St. Louis on the Air on St. Louis Public Radio, 90.7 KWMU.
Support comes from the Missouri Forest Products Association. Missouri produces wood pallets, railroad ties, white oak barrels, hardwood floors, and more. Details on the variety of products made in the state are at choosewood.com.